Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it.
This is chapter 4.5, which is on graphs of sine and cosine. All right, so first let's look at a basic sine curve. So let's look at f of x is equal to just sine of x. All right, and we're going to put this on the xy axis. All right, now along the y axis, we're going to measure just in terms of 1. All right, along the x axis, we're going to measure in terms of pi over 2, so we're going to start at 0. The next value is going to be pi over 2, then pi, 3 pi over 2, 2 pi, so on and so forth. All right, I'll just finish up some more angles there. And I've got negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, so on and so forth. All right. Now sine looks as follows. All right, it starts at the origin, and then it's a wave. All right. After that, it's a wave that by the time you get to pi over 2, it gets all the way to the top value of 1. By the time we get back down to pi, it's 0. At 3 pi over 2, it's negative 1, and at 2 pi, it's 0. So essentially, it looks like this. All right, and it just keeps on repeating over and over again. So you would say it continues like this. All right, now I'm purposely doing this as a dotted line so you can see where the first part of sine is, and this is really the part that we always remember. All right, from 0 to 2 pi. In here, we've got that the entire piece that repeats, that's called one cycle. All right, that is one cycle of the function. The length of it is called the period. So essentially, the cycle itself is the drawing, whereas the period is the length, the x length of the drawing. All right. So in here, the period is going to be just we can say the period is 2 pi. All right. At that point, what else can we say here? In here, the range is y values going from negative 1 to 1. We can just say it's this way, right, in interval notation, negative 1 to 1. This height here represents the amplitude, which in this case is just 1. All right, so that's the amplitude. So it has an amplitude of 1, all right, and it's got a period of 2 pi. Let's really quickly define what an amplitude is because we had not spoken about that before. So amplitude. The amplitude of y is equal to a sine of x, or y is equal to a cosine of x, right, is, or let me say it this way, represents half the distance between the max value and the minimum value. Of the function. And is given by the amplitude is equal to the absolute value of A, right? It is a distance. So in this case, well, since the range, the minimum and the maximum value, is from -1 to 1, well, that entire distance is 2. So the amplitude is half that distance. Half of 2 is 1. So the amplitude here is 1. And notice it's an invisible 1 right there. That would be our A value. All right, so that's what f of x looks like, and that's the definition of amplitude for that. Let's look at, so that's sine. Let's look at cosine. Let's have f of x equal to cosine of x. All right. So once again, I'm going to put this on the coordinate axis. So we have something like that. Let's put this one in the center. There we go. And let's say that the maximum value here, again, is 1. The minimum value here, again, is -1. And we're going to be counting, once again, by pi over 2's. So pi over 2, then pi, then 3 pi over 2, 2 pi, so on and so forth. 5 pi over 2, 3 pi. And the other way, we have -pi over 2, -pi, -3 pi over 2, -2 pi. All right. Now, the cosine wave. All right, the cosine wave starts at the top, then goes down to the middle. Then, by the time it gets to pi, we're all the way down. Then middle, then up, then middle, then down, and it just repeats. All right. So we're gonna hit these values. So in here, in the from 0 to 2 pi, what we remember is that it looks like this. After that, I'm just going to put it as dotted line, but that's just to show you that it continues forever and ever in both directions. All right, and here we've got the same exact idea. This drawing from 0 to 2 pi, that is one cycle, and that's how you spell cycle. That's one cycle. The length of that cycle is the period, which is equal to 2 pi. All right. This is still the amplitude of 1, right? This is also the amplitude. The range is between -1 and 1, just like with sine. All right, so they have the same range, they have the same amplitude, all right? Just if I have sine by itself and cosine by itself, and they have also the same period. The cycle itself is different though, right? Because again, the cycle, you can think of the actual drawing. For sine, it started at the bottom. But anyway, now that we have that, let's add some stuff to this, because what we're going to do here is we want to be able to sketch any sine function and any cosine function by just looking at some transformations. So first, let's look at how to find the period of sine and cosine. So we already spoke about how to find the amplitude, now the period. The period of sine and cosine. So let B be a positive real number. The period of y is equal to a sine of bx and y is equal to a cosine of bx is given by, so we're going to say the period is equal to 2 pi over b. All right, it's equal to 2 pi over b. Now, I do want to make a note here. All right, just a quick note. If b is less than 0, rewrite using the fact that sine of negative theta is equal to negative sine theta, and that cosine of negative theta is equal to just cosine theta. So essentially use the fact that sine is odd and cosine is even to rewrite it so that your b value is not less than 0. All right. So now, let's see how the period affects the graph of sine or cosine. So in here, we're going to be working with cosine. So let's look at, well, first we're going to look at the amplitude, sorry. So let's look at how amplitude affects. All right, so amplitude, in terms of transformation, is the vertical stretch or shrink. Vertical stretch or shrink. All right, so if it's, so in other words, if the amplitude is bigger than 1, it is a stretch. If the amplitude is between 0 and 1, it is a shrink. All right, so let's look at some different examples. So here we're going to look at f of x being equal to 3 cosine of x. We're going to look at g of x being equal to just cosine of x. We're going to look at h of x being equal to, not -3, not yet. Let's look at 1/3 cosine of x. And finally, we'll look at k of x being equal to just -3 cosine of x. All right, so let's see how the amplitude can affect the graph of cosine. And I'm going to put this all on the x and y axis, but I'm just going to look at the first quadrant so you see how things are affected. All right, I want to draw this a little bit bigger. So let me just get some space here. All right. So we're going to get, this is my y-axis, there's my x-axis, and I said first quadrant, but I meant the right half plane. So first and fourth quadrant. All right, so let's go ahead and label some of this. That's 1, that's 2, that's 3. Here's pi over 2, -1, -2, -3, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so I'm just going to look at one cycle here, right? And we're working with cosine. So first, in white, I'll draw cosine. So cosine starts at the top, then goes to the middle, then goes to the bottom, then goes to the middle, and then it goes to the top. So top, bottom, middle, bottom, top. So drawing the wave now, that's what we get. All right, but we already knew what cosine of x looks like, right? We already sketched that up there. Let's look at the amplitude being affected. So f of x being 3 cosine of x. Well, the amplitude is a vertical stretch here, so things are going to go stretch upwards there and downwards here. The zeros are going to stay zeros, right? Because essentially 0 times 3 stays 0. 1 times 3 goes up to 3. -1 times 3 goes down to -3. So that's what's making all this be vertically stretched. So now in here, let's see if I can draw this in one shot. We're going to have a wave. There you go. That was pretty good. That goes all the way like that. All right, everything's being stretched vertically. All right, it's a vertical stretch. For the blue, well, the blue here, our amplitude is 1/3. So things are actually going to be shrinking. All right, so for this, for the blue, things are going to be shrinking. So everything that's all the way up to 1, it's actually going to be just up to 1/3. The zeros stay 0. The -1 is now down to, it's going to be up to -1/3. So around there. Then back to 0. And then finally 1/3. So this is at the height of 1/3. So we end up with something like this. All right. So that is a vertical shrink. All right, because our amplitude, our coefficient, was between 0 and 1. Now let's look at this version over here. Here in red, where we have the amplitude there, it's still 3, but we have to consider what this negative is going to do. If you think about transformations, what that negative does is it reflects across the x-axis. It's going to be a vertical reflection. So essentially, what that's going to do is this value of 1 is now going to go, well, it's not only reflected, but it's stretched by a factor of 3, so it goes all the way over here. The 0 stays the same. This negative 1 here is going to be stretched by a factor of negative 3, so flip it, there's 1, and then factor of 3, so that's all the way over there. And similarly, this 0 is there, and this 1 is all the way down here at negative 3, and we end up with this wave. Close enough. Let's try that again. Nope. There we go. We'll ignore this piece right here. All right. Now, so in there we saw that, oh, let's fix that. We saw how the amplitude affects this. And again, that negative on the outside is just a reflection. All right. So that is amplitude. Let's see how the period affects our functions. All right. So let's talk about the period. So period. The period is the horizontal stretch and shrink. All right. The period is the horizontal stretch and shrink. In here, we were calling the period B, right? So if B is between 0 and 1, it is the stretch. If B is greater than 1, it is a shrink. All right. And by that, we're talking about horizontal shrink. So remember, going this way. All right. So, and for the horizontal stretch, going that way. All right. Now, let's consider what some of these might look like. If I had f of x being equal to sine of 2x, what would that look like? Let's say g of x is just the regular sine of x. And we'll look at h of x being equal to just sine of 1/2 x. All right. Now, in here, let's see what this actually does. And perhaps I should have done these this way, because I'm going to need the space. All right. So if I had something like this, let's say, all right, that's pretty good. In here, I'm going to say this top value over here, that's 1. This bottom value over here, that's -1. Here's 0. And let's go ahead and do it this way. Let's say that this is pi over 2. This is pi. This is 3 pi over 2. 2 pi. 5 pi over 2. I think I'm starting to draw them a little too close. I'm gonna try to make this as accurately as possible, just for the sake of learning. So that's 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. All right. So let's see. I'm gonna start by sketching sine. Sine starts at the middle. Then by the time it gets to pi over 2, it's at the top. By the time it gets to pi, it's back in the middle. By the time it gets to 3 pi over 2, it's at the bottom. And at 2 pi, it's in the center. So this is just going to be, that's awful, something like this. All right, so that's sine. But we already knew what sine looked like. What we're trying to figure out is, how does the period affect this stuff? All right, so in here, in yellow, sine of 2x. Sine of 2x, well, that period of 2, this means that b value there of 2, tells us that the period is equal to, well, 2 pi over b, which is just 2 pi over 2, which is pi. Which tells us that by the time we're at pi, we should be done with an entire cycle. All right, by the time we're at pi, we should be done with one entire cycle. So in fact, what this is going to do is it's going to do a horizontal shrink. right? Because our b value is bigger than 1. So what does that mean? Well, let's actually add a couple more values here. This is going to be pi over 4 and 3 pi over 4. And what it's going to do is, well, everything's being stretched. It's going to be shrunk horizontally. So here's that. By the time we get to pi over 4, we're at the top. By the time we get to pi over 2, we're at the bottom. I'm going to move that a little bit. By the time we get to 3 pi over 2, we're all the way at the bottom. So at pi over 2 was in the middle. And by the time we get to pi, we're at the middle again. So we end up with something like this. All right. And as you can see there, that is a horizontal shrink. All right, because everything was squeezed horizontally. Now let's look at this one over here, sine of 1/2 x. Now in here, well, what's going to happen? This tells us that the period is 2 pi over 1/2, right? 2 pi over b, which is just really 4 pi. So that tells us that by the time we get to 4 pi, that will be one entire cycle. So everything's being stretched over that distance. And what is that going to look like? Well, what it really does is it starts here at the origin again. By the time it gets to pi, it's up here. By the time it gets to 2 pi, it's in the middle. By the time it gets to 3 pi, it's down here. By the time it gets to 4 pi, it's in the middle again. So this ends up looking something like this. Let's draw that a little bit better. There we go. All right. So that's what that function would look like, sine of 1/2 x, right? It was stretched horizontally because our b value is between 0 and 1. And again, that implies that our period, which is 2 pi over b being 1/2, is really 4 pi. So 4 pi is a distance that I need to get through one cycle. All right, so that is essentially vertical stretch and shrink and horizontal stretch and shrink. Now let's talk about translations. Remember, translations were shifting left, right, up, or down. So let's look at translations of sine and cosine. So in here, we're going to say, given that we have a function y is equal to a sine of bx minus c plus d. All right, we're going to talk about what these all mean. Or y is equal to a cosine of bx minus c plus d. All right. The number x is equal to c over b. All right. And how did I get that? I said it obtained by letting bx minus c equal 0. All right. That is the horizontal shift. Now, in general, with trig, we like to call this the phase shift. All right. So the horizontal shift is really called the phase shift for trig. The left and right endpoints of one cycle, the left and right endpoints of one cycle can be determined, let me rephrase this, of a one cycle interval can be found by, so the left would be setting bx minus c equal to 0, and the right would be by setting bx minus c equal to 2 pi. All right. In here, I also have this plus d over here. D will be just the vertical shift. So D is what makes things go up or down in this case. All right. Now, let's see how this affects things. All right, so let's go ahead and start sketching some stuff. So let's get to an example. Sketch. And here I've got y is equal to 1/2 sine of x minus pi over 3. So we're going to start simple here. All right. The very first thing I'm going to say here is, well, what can we say about this function? Well, we've got an amplitude here, right? So the amplitude will be the absolute value of a, which is equal to the absolute value of 1/2. So it's 1/2. That gives us the amplitude. What else should we find here? We should find also the period. The period is given by 2 pi over b. In this case, it would be 2 pi over 1. So it's just really 2 pi, right? B is the coefficient of x there. All right, what else do we need? We need to figure out the phase shift. Well, we'll talk about the phase shift in a second, but actually, another thing that we should consider is there a reflection over the x-axis? And the answer here is no, because this is positive. If this had been negative, then there would be a reflection. So there's no reflection in this case. Now, in here with the phase shift, I want to talk about something that's very related to this. So first, I'm going to say, well, it's bx minus c is equal to 0. So in this case, we have x minus pi over 3 equals 0, which tells us that x is equal to pi over 3. All right, now, the phase shift also gives you the left endpoint. All right, if you notice the way that I define things over here, the phase shift itself is just c over b, but the left endpoint can be found by doing the same exact thing, by setting bx minus c equal to 0. So the left endpoint here would just be x is equal to pi over 3. The right endpoint, we would find it by setting bx minus c equal to 2 pi. In this case, that means x minus pi over 3 is equal to 2 pi, which really tells us that x is equal to 7 pi over 3, right? Because 2 pi plus pi over 3 is 7 pi over 3. All right, now, do we really need to find all these things? Well, let's put it this way. The phase shift and the left endpoint, you're finding pretty much the same thing, just interpreting it differently. The right endpoint is super helpful for this, but the way that I really want you to think about this is not this way, all right? So let me show you how I want you to think about finding these things. We're going to find 5 key points, all right? So we're going to talk about something called the 5 key points. So 1, 2, 3, 4, 5. In these 5 key points, I'm going to have the left endpoint. So this is the left. Over here is going to be the right endpoint. And we're going to talk about how to go from one point to the other. But the left endpoint was setting the inside equal to 0. So we had x is equal to pi over 3. The right endpoint was setting the inside equal to 2 pi. So x is equal to 7 pi over 3. All right, so this is pi over 3 and 7 pi over 3. Now, to figure out what these other 3 points are, all right, in here, what we're going to do is, with the 5 key points, we're going to do some side work. We're going to say, we're going to take the period and divide it by 4, all right? And what was the period? The period was 2 pi. So we're going to take 2 pi and divide it by 4, which is equal to pi over 2. To go from one key point to the next, we're going to add pi over 2 every single time. All right, we're going to add pi over 2. And we should get from the left endpoint to our right endpoint by just being able to add pi over 2 over and over again. All right, so what do we do here? Well, let's think about this. Pi over 3 is the same thing as saying 2 pi over 6. And pi over 2 is the same thing as saying 3 pi over 6. And why do I want that? Because I want to have a common denominator. So at this point, we say, well, 2 pi over 6 plus 3 pi over 6 is 5 pi over 6. 5 pi over 6 plus 3 pi over 6 is 8 pi over 6. But 8 pi over 6 really reduces to just 4 pi over 3. And we said this was 8 pi over 6. 8 pi over 6 plus 3 pi over 6 is 11 pi over 6. And 11 pi over 6 plus 3 pi over 6 is 14 pi over 6. But 14 pi over 6 reduces to just 7 pi over 3. Cool. So we've got our left endpoint, our right endpoint, and 5 key points. These 5 key points are going to be super helpful for when we go to sketch things, all right? So let's look at the sketch of this. Now, the last thing we should ask ourselves is there a vertical shift? So vertical shift, no, right? Because this is the same thing as saying plus 0. So there's no vertical shift, so that means we're staying right on the x-axis. So let's see what this looks like. And we're going to say, well, let this top value over here, well, that has to be our amplitude, right? And what was our amplitude? Our amplitude was 1/2. So this max value has to be 1/2. This minimum value has to be negative 1/2. So that our amplitude is just 1/2. Next thing I'm going to do here is I'm going to sketch the 5 key points. We have pi over 3, 5 pi over 6. Okay. So let's say somewhere along here is pi over 3. Now, I don't care about what I drew on this side, but I care about is how the rest of these are evenly spaced. All right, these all should be evenly spaced. I'm not going to be concerned about this part. So if I evenly space the rest, so this is 5 pi over 6. Actually, let's do it this way because I drew it so large. I'm going to say let this be 5 pi over 6. This is going to be 4 pi over 3. This is going to be 11 pi over 6, and this is going to be 7 pi over 3. And now all we need to do is draw our sine graph off of these key points, all right? And now, well, what was our sine graph? With sine, you have to remember that it is middle, top, middle, bottom, middle. So it ends up looking like this. Right? And that is one cycle of this sine graph. All right? Middle, top, middle, bottom, middle. All right? So, all right, cool. Let's do another one. All right? Let's say that I had something like y, so this example will be y is equal to negative 2 cosine of 3x plus pi over 2. All right, so let's see what this does for us. Well, first, let's find our amplitude. The amplitude was the absolute value of a, in this case, the absolute value of negative 2, which means 2. All right, let's find the period. The period is 2 pi over b. In this case, it's 2 pi over 3, right? Because b is 3. After the period, let's see, is there a reflection? The answer is yes, because of that negative value. All right, so it's a reflection over the x-axis. Is there a vertical shift? The answer is no, because we have a plus 0 at the end there, right? So we know we're going to be right on the x-axis. The next thing I'm going to talk about is the 5 key points. So we have 1, 2, 3, 4, 5. The left can be found by setting 3x plus pi over 2 equaling to 0. So that gives me x is equal to negative pi over 6. The right can be found by setting the inside 3x plus pi over 2 equal to 2 pi. Subtract by pi over 2, 3x is equal to 3 pi over 2, right? 2 minus 1/2 is 3/2. Divide by 3, x is equal to pi over 2. So I've got my left endpoint of negative pi over 6 and my right endpoint of pi over 2. Now, to find the points in between, well, what I need to do here is take the period and divide it by 4, right? So my period was 2 pi over 3. If I divide that by 4, that's going to give me, well, let's write it this way. 2 pi over 3 times 1/4, which is just simply pi over 6. So what that tells us is that to go from one point to the next, I have to add pi over 6. All right, well, negative pi over 6 plus pi over 6 is 0. 0 plus pi over 6, pi over 6. Pi over 6 plus pi over 6, 2 pi over 6, which reduces to pi over 3. 2 pi over 6 plus pi over 6 is 3 pi over 6, which reduces to pi over 2. So there we go. We've got all of our key points. Now we can go ahead and sketch this, all right? So what we're going to do is we're going to say we've got our x and y axis, right? So let's go ahead and draw these. And, well, let's actually shift this a little more closer to the center. There we go. And we're going to say, well, what was our amplitude? Our amplitude was 2, all right? So that means that our max value and our minimum value are going to be 2 and -2 respectively. What else do we have? We have that there's no vertical shift. There is a reflection, so we have to keep that in mind, all right? So the 5 key points were, let's go ahead and sketch those. Let's say that this is negative pi over 6, here's 0, here's pi over 6, here's pi over 3, and finally, here's pi over 2. And what else do we have? Well, those are key points, right? And with cosine, because we're graphing cosine, right? With cosine, it's normally top, middle, bottom, middle, top. That's normally what it is. Top, middle, bottom, middle, top. However, we've got a reflection. So that means we need to start the other way. Bottom, middle, top, middle, bottom. And that's exactly what we're going to do with our graph. So we're going to start at the bottom, go to the middle, go to the top, go back to the middle, and then end at the bottom. So in here, this graph will look something like this. That's awful. Let's draw it slowly. Way better, I guess. I don't know. But anyway, the point is here that we've got our amplitude of 2, and it was shifted to the left by pi over 6 units. Notice that this essentially tells us it's to the left by pi over 6, all right? Because that is our horizontal shift, all right? Or our phase shift. All right, let's do another one. So that was B. C. Let's say that I had y is equal to -1/2 sine of pi x minus pi, and that minus 3. All right, so let's go ahead and see what we have here. What is the amplitude? Well, the amplitude will be the absolute value of a, which is the absolute value of -1/2, which is 1/2. What is the period? The period here is, well, we know it's 2 pi over b, which in this case is 2 pi over our b value is pi, so 2 pi over pi, which is 2. Well, the other thing that we need to consider here is there a reflection? Well, yes, there is a reflection, right, because of this negative value here. Is there a vertical shift? Well, the answer is yes, because we have a -3 at the end there, so it's going to go down by 3. We'll talk about how that affects things. What else do we need? Well, we need to figure out our 5 key points. All right, so 5 key points. And so it's 1, 2, 3, 4, 5. The left-hand point, the left key point, can be found by taking the inside and set it equal to 0. So pi x minus pi equals 0, which means that x is equal to 1. The right-hand point, that can be found by setting the inside pi x minus pi equal to 2 pi. So add by pi, divide by pi, so it's going to get x is equal to 3. Right? Add 1, we get to 3 pi, divide by pi, it's just 3. So our left endpoint is 1, our right endpoint is 3. The next thing we need to figure out is the 5 key points, so the other 3 key points there. Well, what we're going to do is take our period divided by 4. And our period was 2. So 2 divided by 4 is 1/2. So to go from one key point to the next, we need to add 1/2. So 1 plus 1/2, 3/2. And 3/2 plus 1/2, 4/2, which is 2. 2 plus 1/2, well, that was 4/2. 4/2 plus 1/2 is 5/2. And then 5/2 plus 1/2 is 6/2, which reduces to 3. All right. So now let's go ahead and sketch this. All right. So in here, I'm going to start it this way. Let's say that we have, I'm going to draw it there that way. You'll see why in a second. All right. So if I'm going to shift everything down by 3 units, that is the very first thing I'm going to look at here. All right, when I go to sketch this, I'm going to look at if I have a vertical shift. Because I do have a vertical shift of down by 3, well, I'm going to go down by 3. Let's say that's 1, 2, that's 3. And I'm going to consider this the center or the middle of the graph or the wave. All right. What else do we have? Well, we have an amplitude of 1/2. So if -3 is at the middle, the amplitude needs to go up by 1/2. In other words, -5/2, and it needs to go down by 1/2. In other words, -7/2. What else do we have? We have 5 key points. We have them at 1. So let's say that's 1. We have them at 3 and 3/2, at 2, 5/2, and at 3. So that's 1, 2, 3, and this is 3/2 and 5/2. All right. What else do we have? Well, it's a sine function. A sine function starts at the middle, goes up, goes down to the middle, goes to the bottom, and then goes to the middle. However, we have a reflection. So the reflection means that instead of going up first, we're going to go down first, then the middle, then up, and then middle. All right? So middle, down, middle, up, middle. Middle, down, middle, up, middle. And in here, this is what it's going to look like. All right. I guess I drew too much over here, but that's okay. All right. So that's that graph. All right. And we had the reflection, but we also had a vertical shift. So anytime you have a vertical shift, that is the very first thing that you want to consider. All right. When you go to sketch it. Let's do one last one, and then we'll say that we're done for this section. So, example D, I think. Yeah, D. So D. Let's say that I had y is equal to 3 sine of 2x plus 2. Right? And let's see what we can do with this. All right. Now, actually, I'm going to change this up a little bit. Let's say that it was 2x minus pi over 2. And then that plus 2. All right. So let's go ahead and get started. What do we need? Well, we need the amplitude. The amplitude is the absolute value of A, which is the absolute value of 3, which is 3. We need the period. The period was 2 pi over B, which in this case is 2 pi over 2, which is just pi. Is there a reflection? The answer is no, because it's positive there. So no reflection. Is there a vertical shift? The answer is yes. Upwards by 2, right? Because of that plus 2. And now let's get our 5 key points. So 5 key points. So 1, 2, 3, 4, 5. And the left endpoint is by taking the inside, 2x minus pi over 2, setting that equal to 0. So I have 2x is equal to positive pi over 2, x is pi over 4. So there it is, pi over 4. The right endpoint is by taking the inside, 2x minus pi over 2, and setting it equal to 2 pi, right? So add pi over 2, so I end up with 2x is equal to 5 pi over 2, right? Because 2 pi is the same thing as saying 4 pi over 2, and if I add pi over 2, 5 pi over 2, divide by 2, I end up with x, oh, let's rewrite that. I end up with x is equal to 5 pi over 4. All right, so that's up here, 5 pi over 4. The next thing I need to figure out is, well, the rest of my key points here. And the way that I need to do that is I need to take my period and divide it by 4. And the period was what? It was pi. So that divided by 4 is just pi over 4. So if I want to be going from one point to the next, I need to add pi over 4. So just think of this as fractions, right? So 1/4 plus 1/4 is 2/4. In other words, 1/2. 2/4 plus 1/4 is 3/4. All right, so 3 pi over 4. 3/4 plus 1/4 is 4/4. In other words, pi. And 4/4 plus 1/4 is 5/4. So 5 pi over 4. So we know that we got the right values. All right. Now, once we've got this, we say, well, let's go ahead and start sketching. And let's see. We're going to be shifting up by 2. All right. So let's do this. And that's fine. All right. So in here, I'm going to say, well, let's let this height be 2, 4, 6. So this is 5. This is 3. This is 1. This is -1. That's -2. Okay. So because things are being shifted upwards by 2 units, well, I want to look at the center line, or the middle, at the height of 2. So I'm just going to look at this middle line as the height of 2. What else? We've got an amplitude of 3. An amplitude of 3 means that our maximum values are going to go all the way up to 5, and our minimum values are going to be down to -1, because it's 2 plus 3 and 2 minus 3, right? So that's how you get those maximum values of 5 and -1. But now let's look at the key points that we have. We started with pi over 4. So let's say this is pi over 4. Then the next one is going to be pi over 2, right? So, and then 3 pi over 4, pi, and 5 pi over 4. All right. Now, what kind of graph did we have? We had a sine graph. And a sine graph, in general, starts at the middle, goes up, middle, bottom, middle. This one is not reflected, right? It's not reflected, so we don't have to worry about changing that. So it is definitely going to look like that. All right, so let's go ahead and sketch it. From the middle, pi over 4 was the first one. It's going to go up to 5, down to the middle, down to our minimum, down to the middle. So we're going to have here as our graph this. All right. And again, these are just, I'm just sketching one cycle of the graph. All right. That is the end of 4.5.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.